Hello and welcome back to my YouTube channel. So we'll continue with the April 2025 mock paper. And today we'll do question 23. Yeah, I've attached these questions on the previous video on question 22. So you can just go back and check the video that I've done previously on question 22, which make parts of the April 2025 mock paper. So let me read the question. The question 23 had part A and B also. So I'll start with part A. And so I'll read the question. Mr. Bodo Omar is the marketing manager of Tintola Limited. He gathered data on the number of salespeople engaged in a month and the sales made in the last 10 months of the year 2024. So we have year 2024. Then we have months from March to December. Then we have the number of sales people. And we have sales, which is shillings in thousands. Then required, Roman 1, estimate the total sales function using the MS Excel function in bracket regression model. 4 marks. Yeah, so I'll start straight away with that Roman 1. So I'll do my workings down here. Yeah, so what the examiner is asking for is the regression model. And this was a question under management accounting. So under the regression model, we have what we call the Y. Yeah, we do a presentation in forms of Y is equal to A plus BX. Yeah, so this is the model, the regression model. Some books call it the least square method, where we have Y is equal to A plus BX, whereby Y, in this case, will be the dependent variable, while A will be, sorry, let me say Y is the dependent variable, then X is the independent variable. Yeah, so A and B are the constants. We call them the constant. Yeah, we call them the constant. But now in your case, Y should represent, like in this question, Y, you should be able to identify Y and X. Yeah, so when you're given a question like this, it's upon you now to identify the Y and X. And in this case, Y is now the total sales because these are in thousands. Yeah, like in this case for March, it was 23, but that's now 23,000. So Y will be this, while X will be represented by this. And these are a single regression question. Yeah, this is a single regression question. So it means that it only have one independent variable. Yeah, so once you identify that, then you can now go to data. You go to data. Then you go to, you can see data, there's data analysis here. So maybe in your laptop, you might be missing this. So you can as well load it. You can download this if you don't have it in your laptop, because this question, you have to do it with the data analysis tab. So how do you download it? So we'll just go to file, this file here. Then you go to options. Then you go to add-ins, then you click the two analysis that will be able to choose. And because it's already here, so I just allow me to use it. So you click that data analysis tool. Yeah, and I'm looking for regression. So I'll go and select regression and I'll say okay. Yeah, so once you say okay, let me drag this window down here. Yeah, let me check it somewhere there. Yeah, that's okay. Yeah, so you can see the window gives you the regression. So they tell you that input Y range. Yeah, so it means that what will you select for the Y range? So the Y range, I say that you have to identify it here, is the cells. Yeah, so I'll select all that. Then I'll click now the input X range. X range is this. So I'll select all that. Then labels, no. So confidence level, always select the confidence level, which is 95%. So there's output range. That means that where do you want this data to appear? So I'll select it. Then I'll click there. Then I want this data to appear down here. Yeah, so I'll select that. Yeah, that window. Yeah, then I think there's no any other adjustment. So I just say okay. Yeah, so once you say okay, you can see now we have the summary, what we call the summary output. So we have a multiple R square, adjusted R square, standard error, observations are 10. Yeah. So when you're doing this question, always make sure that once you have worked out the summary output, you check at the number of observations. Yeah. So you can confirm from March to December, those are 10 months. Yeah. Those are 10 months. So when you get the observations right, then it means that you have selected everything and you have captured everything. So we have the intercept and X variable A. So they told us the question was, estimate the total sales function using the MS Excel function. Yeah, so the total will be, so the formula, it's equal to Y is equal to A. You can see here we have an interceptor. Yeah, so this intercept represent A. So we'll have Y is equal to 5.4. Yeah, plus, remember it's BX. Yeah, so X variable 1, it means that uh, this is the value of B. Yeah, so B will be 1.4. So I'll just put it to two decimal places, 1.43x. So Y is equal to 5.44 plus 1.43x. Yeah, and that's how you are supposed to answer this first question. So I've said the intercept. This one represent A, while this represent B. Yeah, that's all you have to know. That's all you have to know. And by that, I've just done that question. We are done with part A, and you are able to get your 4 marks. Yeah, the 4 marks is you get this table. Yeah, once you get this table, then you can just answer this. Yeah, so you get a total of 4 marks there. So I'll go to part Roman 2. Roman 2 here. Go to Roman 2. Yeah, so what is the question on Roman 2? What is the examiner requesting us to calculate? Predict the sales made in the month of January 2025. Remember, this was for 2024. When 19 sales people were engaged. Yeah, so we are going to use that formula. Y is equal to 5.44 plus 1.43x. So in this case, the sales people, which is 19, which is 19 salesperson, is what we are going to replace with X. Yeah, because sales is represent S. So just come here and see. Yeah, what they want is the sales. Yeah, so they want Y. So you say Y is equal to, so you just say equals to bracket 5.44 plus, then I'll put a bracket 1.43 times the 19 people engaged. Yeah, because the 19 is represented by X is what represents 19. So just enter. Yeah, so the cells will have around 32.61. And remember, these cells are in thousands, yeah? Yeah, so when you multiply this by 1,000, you can convert it. Even if you leave it at 32.61, there's no problem. They will mark it correctly. Yeah, so the cells will be 32.61 for 19 sales people in the month of January. So you are doing prediction, yeah? Regression is all about predicting the future outcome, using the historical data to predict the future outcomes. So I'll go to now Roman 3, and Roman 3, what are they saying? They've said that Roman 3 required correlation coefficient and coefficient of determination. Then you interpret your result. So it's upon you to identify the correlation coefficient first. Correlation coefficient. Correlation coefficient. So how do you know the correlation coefficient? And we have the coefficient of determination. So let me also write it here. Coefficient of determination. coefficient of determination. Correlation coefficient and coefficient of determination. So the correlation coefficient is the multiple R. So when you go back to the summary, you see this summary, then regression statistics. So the multiple R is what we call the correlation coefficient. In this case, is 0.91. Yeah, it's 0.91. So just come and note it. 0.91. You'll get a mark for that. And coefficient of determination is the R square. Huh? Yeah, this one. So 0.82. 0.82. Yeah, so the examiner said that you interpret the results. Yeah, so what is 0.91, or what does it represent? The correlation coefficient. So it's upon you now to analyze the correlation coefficient and the coefficient of determination. And this is what you do. Yeah, if you are my students, then you add the notes, you will be able to interpret correctly. So they just want an interpretation, huh? Yeah, so correlation coefficient interpretation, that's what they need. So we have 0.91, that's almost 1. So when it comes to correlation coefficient, it always quantifies the strength and direction of a linear relationship between two variables. Yeah, like in this case, between the independent and dependent variable. That's y and x. Yeah, so if it ranges from it always ranges from -1 to +1. So you can see that 0.91, when you round it off, when you reduce this, you reduce let me go to ohm. Reduce the decimals, it will go to 1. So yeah, you can see it changes to 1 automatically. Yeah, so that 0.91 is 1. Yeah, so how are you going to interpret it? Yeah, so it always ranges. I've said it ranges from -1 to +1. So this is +1 in this case. So with value closer to 0, always indicate if it's so closer to 0, like 0.6 and below, then it indicates a weak relationship. Yeah, so just say this is 1. So this will represent, because it's 1, it will represent a stronger relationship between dependent. In this case, the dependent variable is y. Dependent variable bracket y. Yeah, represents stronger relation between dependent variable y and independent variable x. Yeah, that's what you just have to say. And independent variable x. Dependent variable x. Then you go to coefficient of determination. So I've said if it is 0.6 and below, then that's a weak relationship. So you will just replace it with a weak relationship. So we go to coefficient of determination. Yeah, so how do we analyze the coefficient of determination? How do we interpret it? Again, we'll use what we have calculated to interpret. It's 0.82. Yeah, so the coefficient of determination, always, it's often denoted by R square. That's one thing you have to know. Then it always indicates how well a statistical model predicts the outcome, which is always the dependent variable in that case, based on the input variables, which is the independent variable. Yeah, so in this case, the independent variable is the input variable. So it essentially measures the proportion of variance in the dependent variable that is explained by the model. So always a higher R square value that is closer to 1 or 100%, you can see this is 0.82. So when we change this into percentage, it will give us 82%. Yeah, let me change it to percentage. Yeah, it will give us 82%. Yeah, so it's always closer to 1, or so even the 0.8. Let me undo that. Yeah, so even the 0.2, if you reduce the decimal, it will change to 1. Let me see. Let me decrease. Yeah, it's 1. Yeah, so the 0.82, the coefficient of determination, is higher R square value. So it suggests that, let me return the 0.82. Yeah, so your interpretation will be that, how do I put it? You say, the 0.82, that's what we are talking about, suggests the model. Yeah, so this one, it suggests, sorry, it suggests that the model, yeah, the model that we have used, the regression model, that the model explains more of the variability, Yeah, variability just come from the word variability in the data. Yeah, that's how you interpret, huh? Yeah, more. So if it was 0.6 and below, the same way it will say that it suggests that the model does not explain more of the variability in data. Yeah, yeah. Yeah, so it means that if the value is so closer to 0 when it comes to coefficient of determination, that it means that it indicates that there's less explanation on the variability of the model or the data. So that's what you are supposed to do. Yeah, so I'll go to part B of that question. Go to part B of that question. Yeah, so part B, I'm done with this, and you get 10 marks. Yeah, with this, you get your 10 marks. Yeah, with that, you get your full 10 marks. So I'll go to part B. A company intends to start selling a new pair of handheld pliers in the upcoming financial year. The company wishes to establish how many handheld pliers should be sold in order to break even in this investment. So the chief accountant has provided the following data. Yeah, so we have fixed costs. For metal molding machine, it's a million. Plastic grip molder, 250,000. Sander, 50,000. Then we have variable cost per unit. We have the packaging material is 400. Raw material, 700. Grip metal, 200. And shipping is 75. Yeah. Then additional information. Number one, the marketing department estimate that they could sell the new pair of handheld pliers for shillings 1,500 per unit. So let me just indicate here that the selling price per unit, because this will be very key, this information, selling price per unit will be 1,500, so 1,500. And that the project sales will average 16,000 units per month. Yeah, so sales in units, the projected. So that's what we call the budgeted sales. Yeah, budgeted sales. Yeah, in units. Yeah, let me just say budgeted sales units. Let me just say bracket units. Yeah. So it will be 16,000 units. Per month, yeah, because we're doing this per month. So number two, the company wishes to break even and to start earning profit within the first month. Oh, that's okay. Number three, the target profit level at the end of the first month is shillings 250,000. So I'll also write that target profit. It is 250,000. Yeah, I always tell my students to analyze questions in this order so that it makes your work easier, yeah, even as you approach the question. Yeah, so required, number one is the number of units required to break even. Yeah, so I'll do that working. Let me do it down here. So this is part B. Yeah, so the first question is the break even. They'll say that the number of units required to break even. Yeah, so we know at break even point is whereby total revenue is equal to total cost. Yeah, so it means that at break even, profit is 0. Yeah, and at the same break even point in units, Break-even points are specific that we calculate the break-even points in units. So you just come here and say break-even. Break-even. They talk about point or yeah, the number of units required to break even. Yeah, so that's break-even point in units. Yeah, even point in bracket units. Yeah, so the formula. Yeah, you have to know the formula. This is a question. You just have to know the formula. So what is the break-even point in units formula? So the formula is equals to break-even point in units equals to fixed cost, total fixed costs. Yeah, you can say total or just say fixed costs. Yeah, you divide by the contribution margin per unit. Divide by the contribution margin per unit. Yeah. So you can see here, well, do we have the fixed cost? Yeah, the question gave us the fixed cost. So this was the fixed cost: metal molding machine, plastic, grip molder, and sander. So I'll sum all this to get the total fixed cost. So you just sum this. You just come here and say auto sum. Yeah, so the total fixed cost is there. Yeah, and also allow me now to also look at the variable cost per unit, the total variable cost per unit. So I'll also sum this. Total variable cost per unit. So my total variable cost per unit is 1375, while the total fixed cost is that, yeah. So for us to break even point in units, we have to have the fixed cost, which we already have, but we don't have the contribution margin per unit. So therefore, I'll calculate the contribution margin per unit. Contribution margin per unit. Yeah, so what is the contribution margin per unit? So the contribution margin per unit is always the selling price minus the selling price per unit minus, let me write it, selling price per unit minus variable cost per unit. Variable cost per unit. Yeah, so do we have selling price per unit? Yes, we do. Yeah, yes, we do. So I'll just say equals to, what is my selling price per unit? It's here. The selling price per unit was 1500. Yeah. So therefore, minus the variable cost per unit. So what is the variable cost per unit? Is the value that I sum up here. So I'll subtract that to get the contribution margin per unit. So my contribution margin per unit is 125. Yeah. So the contribution margin per unit. Yeah, it's okay. Will be 125. So therefore, I can be able to calculate the break-even points in units because now I have the contribution margin per unit. Therefore, it will be equals to the fixed cost, which we have here, just equals to the fixed cost is here, 1.3 million. Yeah, you divide by the contribution margin per unit, which is 125. Yeah, so the break-even point in units will be 10,400 units. 10,400 units. And that's how you're supposed to do part A of that question. And you get your 4 marks. Huh? Yeah, so how is this marks awarded? Eh? Yeah, you can see by you getting to know this, you'll get 1, 1, 1, 1. So those are 4 marks. Yeah, so I'll go to part, this was Roman 1. Huh? Yes, I'll go to Roman 2. They said, based on the projected monthly sales, calculate the margin of safety, comment on your answer. Yeah, so margin of safety is what we are looking for. So it's upon you to know the formula for the margin of safety. Yeah, so what is the formula for the margin of safety? So the formula for the margin of safety is the budgeted sales minus break-even sales. Yeah. So it is budgeted sales, yeah, the actual sales, budgeted sales minus break-even sales. Yeah, that's how you can, that's the formula for the margin of safety minus break-even sales. Yeah, so here, we love to look at the budgeted sales. Do you have budgeted sales? So we'll first calculate the budgeted sales here. Yeah, so how do we get the budgeted sales? We were told under additional information, yeah, that the company, number one, the marketing department estimate that they could sell the new pair of handle pliers of shillings 1,500 per unit, and that project sales will average 16,000 units per month. Yeah, so we are going to look at the total sales for that month. So we budgeted for 16,000 units per month, but each unit has a selling price of how much? Of 1,500. Yeah, so the total budgeted sales therefore will be uh, budgeted sales will be 1,500, which is selling price per unit, times 16,000 units, which was the budgeted sales per month. So this will be the budgeted sales. Yeah, so we already have the budgeted sales. So what we don't have is the break even in sales. Yeah, break even point in sales. Yeah, so we are going to calculate that. So the break even point, break even point, bracket sales. Yeah, this is the actual sales. Yeah, in shillings. Yeah, the actual sales in shillings. Sales. Yeah, yeah. So what is the formula? So the formula for the break-even point in sale is the total fixed cost over contribution margin ratio. So I'll write that here. So I'll just say fixed cost FC to save on time. You divide by contribution margin, which is CM ratio. CM ratio. Yeah. So in this question, what do we have? We have the fixed cost because already we have used it here. But what we don't have is the contribution margin ratio. So I'm going to calculate the contribution margin ratio. Yeah, so contribution margin ratio. So what is the formula? So the formula for the contribution margin ratio is the contribution margin you divide by the selling price per unit. Yeah, so the contribution margin. So I'll say contribution, which is CM. Yeah, allow me just to use that. You divide by SP. But remember, all this selling price is per unit. Huh? Yeah, so therefore, the contribution margin, which is CM, contribution margin ratio, will be, because I have contribution margins, it's here, per unit, it's this one. Yeah? So it's just equals to this. Then I'll divide by the selling price. So what is the selling price? The selling price we are given here per unit was 1,500. Yeah. Yeah, and that you get your contribution margin ratio. So once you have that, now you can go backwards and calculate the break-even point in sales, because now you have the contribution margin ratio. So therefore, the break-even point in sales will be equals to the fixed cost. So what is the fixed cost? So the total fixed cost is here. This value, 1,300, you divide by the contribution margin ratio, which is this. Yeah, so your break-even point sales will be this amount. Yeah, so you remember, we were calculating the margin of safety. So therefore, what will be the margin of safety? So margin of safety, we'll say the formula is budgeted sales minus break-even sales. Yeah, so you just equals to budgeted sales is here. You take that, you subtract break-even point in sales to get the margin of safety. Yeah, so the margin of safety was around 8.4 million. Yeah, so that's the what we call the margin of safety. Yeah, so it's 84. Yeah, so this is what I will mark as the correct answer. Yeah. Yeah, so interpretation will say it's a positive margin of safety. It is a positive margin of safety. Positive margin of safety. So that's how you're supposed to unlock part B. Yeah, no, Roman 2. Part B, Roman 2 of that question. The Roman 3, the last part, is the number of units required to earn target profit at the end of the first month. So you look at the formula. Yeah, so the last part, I'll do it here. So it is the number of units. So that's what we call the required sales units. We just say required. So you lose what we call CVP, the cost volume profit analysis, yeah, the CVP. So you'll say the required required sales in bracket units will be equals to, this is the formula, yeah, for you to get the targeted, yeah, because I've said that what they need is the target, no, sorry, the number of units required to earn target profit. So the formula is the required units, yeah, which is sales, equals to bracket. You'll have fixed cost, so I'll just say FC plus target profit, which is TP. You add to TP, then you divide by the contribution margin per unit, contribution margin per unit. So you divide all this by the contribution margin per unit, not ratio. Okay. Yeah, so let me put it that way. Yeah, so we have everything now. So I just say the required sales in units. So sorry. So required, let me just write it once again. Required sales in bracket units. Let me delete that formula. Yeah. So I'll be able to work it here. So our fixed cost is there. So I'll say equals to bracket fixed cost plus target profit. So our fixed cost was yeah. We'll add to target profit. The target profit is here, 250. Then you close the bracket. Yeah, so let me work with that first, just to be accurate. Let me add fixed cost plus, yeah, so after getting that, then now the required sales in units, I'll divide by what? I'll divide now by, this value I'll divide by the contribution margin per unit, which you already have. So just equals to this. You divide by the contribution margin per unit is here, over 125. Yeah, so the number of units required to earn target profit at the end of the first month is 12,400 units. 12,400 units. And that's how you are supposed to do that question. Yeah. As simple as such, and you get your 20 marks. Yeah. So this is an area that business data analytics you will be tested. Yeah, even on your paper next week. Yeah. So continue subscribing to my channel, like the videos, share. Yeah, so that we can reach many people. And even our August intake is ongoing, so you can reach me through my number on my YouTube channel. Yeah, so that we start early, so that you'll be able to pass this paper on your first, second, or third attempt. So thank you so much for watching. Keep on subscribing. Have a blessed evening, afternoon, or morning, wherever you are. Thank you so much.